Hi, Assalamu alaikum, peace to you. In this video, we will design a single footing foundation. So example 12.2, design a square column footing for a 16-inch square tight interior column that support a dead load of 200 kip, live load of 160 kip. The column will be reinforced with 8 number bar, and the base of the footing is below 5 feet. The soil weight is 100 pound per feet cube. Fy 60 ksi, Fc prime 3 ksi, and Q allowable bearing pressure is 5000 psf. So the effective bearing pressure 5 feet below the soil is 4400 psf. The design problem from a design of reinforced concrete from a Nielsen book. So I am going to start from a new model. First of all, I will select the unit system because our problem is in the FPS system. So I have selected the US customary unit system. So now I am going to click the grid system. Here I will put 2 grids in the X direction and 2 grids in the Y direction with the spacing of 20 feet by 20 feet in each direction. Okay, so here we can see our model. In X direction is 20 feet and Y direction is 20 feet. The after calculating the approximate or area of the footing, that is 81 feet square, so I have selected 9 feet by 9 feet the footing area size. So first of all, I am going to define the materials, the concrete and steel materials. So Fc prime is 3 ksi and Fy is 60 ksi. Here I have put 3 ksi. Okay, now I am going to define the steel bar, that is of 60 ksi. There is already defined 60 ksi grade, so I will just change the name of it, and you can also define 60,000 psi grade steel. Okay, now I am going to define the slab properties. Here is slab of the footing. I have selected 24 inch, which is 2 feet slab thickness. And I have also selected the type. So now I am again defining a new slab, which is a stiff portion of slab, which will show the mm, uh, central portion of concrete slab, central portion of column, that is 24 inch. So first of all, I will draw the slab that is of 9 feet by 9 feet by selecting quick draw areas around points. So here in the X direction, X dimension, I will put 9 feet, and the Y dimension, that will be 9 feet. And the property is footing. So here, after just one click, this slab will be drawn of 9 feet by 9 feet. Now I will draw this stiff portion that will be indicate the 16 inch square tight column, 16 inch the software automatically understand and convert into feet. So I will just click that portion here. You can see it is showing that column of size is 16 inch by 16 inch. Now I have drawn the point so where I can apply the loads. In our example there is only dead and live load, so that's why I defined it dead and live load patterns. And for the designing of the foundation according to LRFD method, so we have to define the two combinations, what that is 1.4 dead and 1.2 dead plus 1.6 live, that is according to ACI code. So now I will define the boundary conditions, that is for the soil. So like I will define here the modulus of subgrade, that is basically the bedding pressure divided by the allowable settlement. So here I am defining the soil properties. In this problem, that is effective bedding pressure is 4400 psf and the allowable settlement is for this isolated footing, that is 1 inch is equal to 25 millimeter. So here after dividing the bedding pressure divided by settlement, that is equal to 452,800 pound per feet cube. Now I will click the slab. After selecting the slab, I will assign the support data, that is soil bearing pressure at the foundation. Now I have clicked the point and I will apply the loads. That is dead load is 200 kip and live load is 160 kip. 200 kip. Okay. So now I will select again and apply the 160 kip live load. To check that loads have been applied successfully, you can check by clicking the right click on that point and you can see the loads. I am defining the design strips along the X and along the Y direction so that I can see the results by strip method. I will prefer to draw the design strips manually, so that's why I am defining here the strips manually. Change the name for to draw in the Y direction. Okay, now I will run design and analysis. Before running, I will save the model design of isolated footing using CSI Safe software. After running the model, you can see the deformations according to deformation shape against the load combination 1.2 dead plus 1.6 life. Now show reactions against the load combination for the soil bedding pressure, for the soil pressure under the footing. So here that much amount of pressure is under the footing, so we have to provide more reinforcement to control the pressure, to control the movements, shears, etc. Now I am seeing the moments in the layer A of strip. In the layer B in the y direction, here the movement is 399 kip per feet square. So also see in the book example 404 kip feet, that is okay. So here also the same results in the y direction of the movements. In the show slab design, I will go through both methods by FEM, finite element method, and by stream method. First of all, by finite element method, in the direction 1 top rebar, in the direction 1 bottom rebar. Now strip based, only at the strips locations I can see the reinforcements top and bottom. In the layer A, mean in the x direction, that is. Now in this total amount of reinforcement required. Similarly in the y, the total amount of rebar area required in the strip, so that is per square feet. So now I am providing the reinforcement against the applied loading. So here I am changing the spacing here, that's okay. Now I am optimizing the reinforcement apply. If I provide number 4 at the rate of 6 inch spacing, that is not enough, so I am reducing the spacing. So number 4 bar at the spacing of 4 inch in the x and y direction, that will be okay and satisfying the against the applied loading. Now I am running the detailing. Here after running the detailing, I can see the footing layout plan, footing table, and footing bill of quantities, mean how much an area of reinforcement required. Here is showing number 5 bar, but I have provided number 4 bar, so I will go in the preferences and change the preference bar number 4, so that I can optimize accordingly. Column strip number 4. Here I have set in the preferences number 4 bar. Okay, now I am going to again running the analysis, running the detailing, sorry. So now check in the footing bill of quantities against number 4 bar, total 441 fit square length required, fit length required. Thank you.